the Masnui telescope has achieved a major scientific breakthrough. One of its most important findings is a faint dark dot visible in images from the James Webb Space Telescope, a weak signal with very little energy that could be a planet, a very large world out near Neptune. If this is true, it would challenge our assumptions about how observatories are designed. In just a few days, the Masnui analysis and the Webb images have done what would normally take a century of work by researchers. This new object appears to be a planet roughly 10 times the mass of Earth, orbiting near Neptune, possibly even closer than expected. That raises the first question: how did Masnui find it, and what data is it working from? The answer is simple. Masnui is an advanced AI used by NASA that analyzed the data stored on NASA's servers. Many of the new images looked like Webb images. Those were compared with older images, and a faint, dim dot was detected. This object moves relative to the background stars in the Milky Way. It's not a fixed point. The AI system can process millions of pixels at once without being overwhelmed by the volume or noise in the data, which lets it detect many faint signals that human reviewers would miss. Instead of getting distorted by the sheer amount of light and size in the data, the system picked up a new planetary signature. James Webb's images are the most detailed we have. Millions of light-sensitive pixels are recorded. Each bright red pixel can be a clue, a new object. NASA servers hold thousands of such images, many of which are not widely distributed or remain under further investigation. No single scientist, or even a team of 1,000 scientists, could realistically inspect every pixel in every Webb image. That would take millennia. But Masnui's AI can do it quickly, like finding one faint star in a stadium full of 100,000 bright lights. Unlike humans, AI doesn't blink or tire. Nothing escapes its systematic scan. The AI detected movement of a very faint, low-light source across images taken over years. A bright red candidate emerged. Researcher Terry Longfan used a more traditional approach to verify this. He layered images and compared them visually. He used images dating back to 1983 from NASA's IRIS telescope, data from a Japanese farscope, and images from Hubble and James Webb. A change showed up. In the 1983 images, there was a point that didn't appear in the 2006 images, or at least it had shifted slightly. A new object, not present in the IRIS data, appeared a few centimeters away in the registered frames, an amount corresponding to motion for a body at roughly 700 nautical miles in projection from the frame's reference. In other words, the object shows measurable relative motion. But here's the puzzling part. The object's bright red emission is stronger than expected, brighter than Neptune. Based on gravitational estimates, it's smaller than Jupiter but larger than Neptune. Perhaps comparable to Neptune, perhaps a twin, or maybe something far stranger. We simply don't know yet. Until James Webb collects targeted follow-up observations, we can't be certain. Webb is the most powerful space telescope for hunting cold, distant worlds. An object moving at that distance would be extremely cold, on the order of 30 to 50 Kelvin, about minus 243 degrees Celsius. Such an object emits very little visible light. The red signal we detect is thermal emission from the body itself. Webb has already detected several faint thermal rings and tiny moons around distant planets like Uranus and Neptune, so this detection is not impossible. Webb can image a wide swath of sky and then zoom in on a tiny region. If we can localize this candidate precisely, Webb could point at it and reveal its appearance and details. That raises many exciting questions. If a Neptune-like object is found outside the usual planetary plane, does it have rings like Saturn? Does it have moons like Jupiter? Is it alone? Or are there companions? Discovering such an object at this distance would tell us about conditions in the early solar system. Several hypotheses about its nature have been proposed. One possibility is that it's a very cold gas giant similar to Neptune. If there's another large body nearby, Interactions in the early solar system could have ejected this object into a distant orbit. Why would that happen? Astrophysical models show that the presence of an additional massive body can strongly influence the configuration of a planetary system. It can shift orbits of planets, alter inner system dynamics, and even trigger instabilities. This leads to a speculative, almost dramatic, idea. What if the system's dynamics knew that Earth would later develop life and that stable conditions were needed? Could interactions early on have removed or ejected potentially disruptive bodies to stabilize the inner system? That idea ventures beyond conventional astrophysics into philosophical territory, suggesting objects may interact in ways that help shape a system's long-term habitability. It's a provocative hypothesis, but currently more philosophical than scientific. Another hypothesis treats the object as an interloper. Perhaps it originated in another stellar system. Mathematical models show this is possible. If the object's incoming velocity and path are right, the magnetic and gravitational interactions could capture it into orbit. In that case, we might be looking at a visitor from a system billions of years older than our Sun, an object formed in a different environment with a strange composition and ancient history. It could be a body that has plunged into an extremely cold atmosphere under high pressure, an alien-like world as foreign as a human transported to the moon would seem. At this stage, we must be cautious. The candidate is compelling, but confirmation requires more observations and careful analysis, especially targeted observations from Webb and other instruments. If confirmed, this discovery would profoundly change our understanding of the outer solar system and the processes that shaped it.